Assalamu alaikum, sir. Today I am going to present a statistical analysis based on graveyard management dataset, which the last digit of my ID. That's why I choose graveyard. My name is Fahmida Shah and my ID is 1460, Department of Software Engineering, Section B40, batch. Now, in this presentation, I will briefly discuss the dataset and then explain three hypotheses. These include a one-sample t-test, independent samples t-test, and linear regression using SPSS. Finally, I will explain how a decision tree was constructed using big ML. Here is my graveyard dataset. Now, firstly, we have to know what is a hypothesis. A hypothesis is a testable statement about a population. Here we have the two hypotheses. The number one is null hypothesis and alternative hypothesis. In null hypothesis, no effect or no difference. And in alternative hypothesis, there is an effect or difference tested using statistical methods. We make decisions based on the p-value. If the p-value is less than 0.05, we reject the null hypothesis. The first test is a one-sample t-test. The research question is the average number of graves significantly different from 2500? Null hypothesis that the mean number of total graves is equal to 2500, and the alternative hypothesis states that it is not equal to 2500. In SPSS, the test variable used the total graves and the test value was set to 2500. The decision was made based on the p-value. Now see what is the p-value. After calculating one sample t-test, we found the t-value is less than 0.01, which is very. We can see that the p-value is less than 0.001, which is less than 0.05. From the one sample t-test, the mean number of total graves is 2623. That means this is the very high, and this indicates that the average number of graves is significantly different from 2500. Therefore, we reject the null hypothesis. Secondly, here is the independent sample t-test. In this, the research question is there a difference in total graves between public and private graveyards? Hypothesis is public equals to mean private, and hypothesis 2 is mean not equals to private. Independent sample test, we see that Levin's test significance value is 0.159, which is greater than 0.05. So we assume equal variances. The two-tailed p-value is 0.714, which is greater than 0.05. Therefore, we fail to reject the null hypothesis. This means there is no significant differences in total graves between public and private graveyards. Now, the linear regression. In linear regression, the research question is, does year established predict the total number of graves? There are two hypotheses. Number one, year established has no effect on total graves, and second hypothesis is year established has a significant effect on total graves. Now see what happened in after calculation. After calculation, we see that from the regression analysis, the ANOVA p-value is 0.70, which is greater than 0.05. The R-squared value is 0.002, meaning only 0.2% of variation is explained. Therefore, we fail to reject the null hypothesis. This shows that year established does not significantly predict the total number of graves. Now, in decision tree, using big ML, here are the total variable, grave condition, good, average, poor, and the input variable is location, grave type, year established, and total graves. After inputting our graveyard dataset, a decision tree model was conducted to classify grave condition. This model generated clear decision rules based on grave type, location, and total graves. This helps predict whether a graveyard's condition is good, average, or poor. Now, in the conclusion part, the one sample t-test shows a significant difference in average grapes, while the independent t-test and regression analysis show no significant relationships. The decision tree provides a useful predictive model for grape condition classification. So, that's all from me. Thank you for listening. Thank you, sir.